Okay, we are looking at a right triangle here. And I know it is a right triangle. This is a 90-degree angle because this little notation in the corner means right angle. And I have an unknown side. Okay. Now I can't do the Pythagorean theorem because to do the Pythagorean theorem, I would need 2 out of the 3 sides, and I only have 1 of the 2 legs. So right now, what we've been doing is we've been studying slope ratios. So I can solve this by using a slope ratio because any triangle that has a 22-degree angle and a 90-degree angle would be similar to any other triangle with the same thing, with a 22-degree angle and a 90-degree angle because of angle-angle similarity. So I have a trig table here, right, that has, we filled out one of these in class, but what this has on it is a slope ratio for a 22-degree angle. It means from the 22 degrees, what's the rise, what's the run, what is the slope ratio? And in this case, it is 2/5. So I could use here the slope ratio. Now it's a little bit different here because the 22-degree angle is not sort of set up as a slope ratio here. If we turned it this way, this looks a little bit more like rise over run. So I could take my slope ratio for 22 degrees, which is 2/5. So I'm going to steal that information, 2/5. And maybe I'll write that over here. That's the slope ratio. That is 2/5. For the 22-degree, oh, there you go. For the 22-degree angle, the slope ratio is 2/5. So that's going to get set equal to the ratio here that I see when I look at this in terms of a 22-degree angle as a rise and a run, 70/y. So that would be equal to 70/y. Now from here, I can solve with cross products. It's going to be 2 times y, which is 2y, and 70 times 5. And I can do this in the calculator if you want, or it's 7 times 5 with a 0 on the end, right? 70 times 5, 350. And then divide both sides by 2. 350 divided by 2. 175, right? The previous answer divided by 2. So y is 175. So that's the height of that missing side. Now, some of you guys might be looking at that and going, that was really weird the way I had to turn the triangle. There is another way to do that. I can figure out what this angle is right here. It's a complement to 22 because these two angles together need to add 90 so that when I combine it with this 90, I get 180 degrees, right? If I take my 180 degrees and I take off this 90-degree angle, these two angles left together have to add up to 90. So I subtract 22, and this is a 68-degree angle. And knowing it from here might be a little bit more easier to sort of see how it relates to the slope ratio because it's already set up with rise and run. So I could do the same thing and go to my 68-degree angle here, and I can just steal from this table the slope ratio, the rise over the run, 5/2. So from 68 degrees, my slope ratio, we'll do 68 degrees, keep it color-coded, slope ratio, 5/2. So I take my 5/2, and I can set that equal to y/70. And again, the reason that I can do that is the slope ratio comes from a triangle that has a 68-degree angle and a right angle. Well, this has a 68-degree angle and a right angle. So because of angle-angle, those two triangles are similar, which means their sides are proportional, which means I can set up one slope ratio equal to another. And then look what I get here. I actually get the same cross products. 5 times 70 is 350. That equals 2y. And hopefully, unsurprisingly here, I would get the same answer, right? I divide both sides by 2. Just a smidge. And we get y is equal to 175. Right now, I definitely would not solve this triangle twice, but I wanted to show you that both ways work. You're going to get 175 whether or not you look at it from a 68-degree angle and use your slope ratio y/70, or if you go from the perspective of 22, use that slope ratio and do 70/y. Okay, hope that's helpful. Message me anytime with questions.